Hello, sir.
Hello.
Am I audible, sir?
Yes, I'm audible. Totally.
Good, good afternoon, sir. Myself,
Good
Dr.
afternoon.
Sanjay Kumar Padalia, sir.
Okay, nice to meet you, sir.
Thank you,
First
sir.
time.
Thank you. Yes.
Mhm.
So let us start, sir.
Okay, please.
So this is day 5. Day 5, September 18. This is last day and concluding day, validity day for the 5-day conference from 14 to 18. Welcome again. Our guest today, invited lectures are given by Dr. Vishnuji Sarkar from Yonsei University, South Korea. Welcome, sir.
Thank
And
you.
Dr. Neeraj Dhiman from Graphikira Hill University, Dehradun. Welcome, Dr. Sir. Now, we have with us this time Dr. Vishwajit Sarkar will deliver a talk on the topic applications of sustainability in supply chain and management. So I would like to invite first Dr. Sarkar. He is from far from India, so this is best way to connect with Dr. Sarkar. So we have a brief biodata of Dr. Vishwajit Sarkar. He is in the Department of Industrial Engineering, Yonsei University, South Korea, and presently his research status is the supply chain management and industry during 1720, according to science data
Thanks.
source Scopus. During last 3 years, his topic is top tray science publication in 31 per year. And the academic profile is degree university post postdoctoral fellow, Busan National University, Korea. Degree Doctor of Philosophy, Applied Mathematics, Operations Research from Jadavpur University, India in 2010, and Master of Philosophy in Boolean Polynomials, Annamalai University, India, and degree Master of Degree Applied Mathematics, Operations Research, Jadavpur University, India from Jadavpur University in 2004. And he has a lot of experience in teaching experience in mathematics. Busan National University, Vidyasagar University, Yan
Yonsei
Hanyang,
University.
yeah,
Hanyang University and then
Hanyang
Yonsei University.
University, yes, Yonsei University then. So he published more than 182 papers in SCI, SSI, and SCI journals, and he also done a lot of work in mathematics. He published more than 3 books in national and international publishers, and he has technical skills also: C, C++, Mathematica, MATLAB, and Fortran and Python. And he also done some important projects in 5 research projects he has. And he is also editor in chief, Journal of Engineering Applied Mathematics 2015 and 17, Sustainability Chain Management, Frontier Publishers 2019, and this project editor in chief he is in continue. uh, Guest editor of special issue, Mathematical Problems in Engineering, Hindavi Publishers, Risks, MDPI Publishers, Clean Technologies, MDPI Publishers, and he is also editorial board member of African Journal of Business Management, Mathematical, uh, ITIRNA since 2012, the Yuglo Journal of Operations Research, Annals of Pure and Applied Mathematics, Journal of Society of Korea Industrial Systems, Global Journal of Further Mathematics, Asian Journal of Economics, Insights, Energy Science, American Journal of Operations Management, Inventions, MDPI Publishers, Journal System Dan, this type of journal from, I think, from Germany. Environmental
I guess
Science,
I
yes,
guess from Singapore, sir.
Singapore, yes.
Yes.
Environmental Science, Ames Press, International Journal of Engineering Informatics, Open Journal of Statistics. And he has also delivered talks in more than 24 talks he delivered in different uh, areas and different universities. And he is also reviewer of journal of 70 SSI, SCI, and SCI index journals. International, he has some international activities. Worked as the visiting researcher in Tecnológico de
Jose Montero.
Montreal,
Yes, in Mexico.
Mexico, sir, and Busan National University, South Korea, in in the year 2012. Membership of Learned Society, Calcutta Mathematical Society, Operations Research Society of India, Korean Society of Industrial Research Engineering, Association of Inventory Academicians and Practitioners. He got scholarships also, CSIR, JRF, and so on, and achieved many awards. So I think I have seen longest biodata. So now I would like to invite Dr. Sarkar. He will deliver a talk on the topic uh, applications of sustainability in supply chain management. So it is very uh, good and privilege for the Department of Mathematics, SGRR PG College, to invite Vishwajit Sarkar sir. He take this. Thank you, thank you. So you will deliver your
Thank you,
lecture.
sir. So thanks for the organizing of this webinar. So, and through this way, I can get at least so I can get the information about so many researchers in this field. Even there are so many participants, even I do not know that who is working on which area and which is this talk will be really helpful for them or not. So what I'm doing now, so I'm just doing the basic thing in my research. I'm trying to incorporate there, and let me suggest something that for the researcher who will work for this way, and this thing will be helpful for them. So thanks for the webinar for presenting this, at least the platform where we can present this type of things to the students. Thank you very much. So let me share my screen first. So is it visible now?
Yes, sir. Yes, sir.
Okay, so let me start. So what I will say about that topic is that the application of sustainability in a supply chain management. So this is the area where the main focus is going on the sustainability issues, that supply chain is forming by the different it may be the domestic supply chain, it may be the global supply chain, but the question is the sustainability is coming, that is it really sustainable or not. So that is the main theme I would like to explain for today's topic. And what I would like to say specifically, that where we can use sustainability, how do we model with the mathematical application, and how this sustainability really help the society. So that I would like to say today. And if that those students that who are working on this area, so I just recommend some research problems also, so that is not developed yet. So if anyone is working on this area, or anyone is would like to work on this area, so then they will also work on this type of research problems. So these about me, that professor already said so many things about me, so I'm skipping this one. So these are the content slide, that what exactly I would like to say today. So first, let me define that what's the sustainability is, and based on what it is going on. And then what is the necessity of the sustainability, that why should we study, why should it be the research topic, and what is the importance of it. And next, I will explain about the different approaches of the sustainability. That means how this sustainability is a word, and how it will be affected on the supply chain, how we can make mathematical model using the words sustainability. And then I will show something that the application of the supply chain management. And finally, some research problem, that open research problem, which I have published in different journals. So how to extend those model in the direction of the sustainability, so that I will explain. So first, let me explain about the basic thing about the sustainability. So what is the main content is there, that we should be alive with the help of nature. Means we should not destroy the nature properly. So that, okay, destroy the nature and we are gaining more profit from the industry's perspective. That should not be done. So the main aim of the sustainability is that we will work in our way, but such that there will be no disturbance on the no problem coming from the nature side or the environmental side. So this is the main aim for the sustainability issues. So based on this thing, so the sustainability things are defined in this way. One is that the economical, second one is the environmental, and third is the social one. So if an industry will continue forever for a long time with more profit, so they should think about this type of things. First one is that economical, that always industry bother about this one, that how to gain more profit. The second one is the environmental issue also, because if every time this type of nature problem will come, so industry cannot gain more profit. So there will be some big problems will come. So that's why they should take care about the environmental issues also. And the last one is the social issues. What does it mean, the social issues? Just like, suppose how to create the job. So this type of things, that if any industry is formed anywhere, suppose think about a rural place, and there the industry is formed, newly industry, and then definitely there will be so many people will get job that in that industry. It's quite natural, because they need people to work in that area or in that industry. So that's why several people can be recruited from there. So that means that if the industry is forming, so these three types of benefit can be done by this thing. And industry should take care about these three things also: economical, environmental, and social, such that they can maintain sustainability forever. Forever means it's a big large word, so it should be for a long time. So these are the main three pillars: economic one, the second one is the environmental, and third one is the social. But if you go for the previous, just before 100 years or something, so earlier, the traditional industries, when they formed, they do not bother about these environmental and social issues. Social issues, sometimes it should be taken care, but environmental, no one want to bother. Even though when we are driving the car, we do not bother how much carbon emission is going on. So we do not bother about these things. But nowadays, the situation is so serious that global warming is increasing continuously, and every year that near about 2-degree temperature is increasing for the earth. So if, and you already see several places that the duration of the season is changing. So suppose if it is a summer season, so okay, this summer is delaying. If it's a winter season, so it is delaying. Winter season is there, but total duration, if it is 3 months, so it is reducing 2 months or 1 month, something like this. So everything is changing because of this type of situation. So that's why industry should take care about these issues very carefully. So how to explain these three pillars? One is for what I said, for economic benefit, and the second one is the social, and third one is the environmental. So in terms of uh, economic benefit, so the two aim should be very clear. One is that the industry should be careful about their more profit with different strategies, along with uh, that they may think about that anyhow the cost should be reduced. Similarly, if they are thinking about the social benefit, they can do this way: they can create more jobs for different criteria, so they can do this thing. They can create different responsibility, they can make more human resources, so that the human society will get the long term benefit, and in such a way that the community development will be going on. Similarly, the environmental benefit, that the global warming, air pollution, soil pollution, and several types of pollution can be reduced easily. So that are the three pillars. Those are the three pillars, that the economic benefit should be done, social benefit should be done, and also the environmental benefit should be done. So that is the main three pillars of the sustainability. Just So this is, we say it as a human ecosystem equilibrium. What is this human ecosystem equilibrium? That if we do not follow these three things, that means steps for the pillar as like a pillar for the sustainability, we may have this type of disasters continuously. So that's why we should be careful about this type of situation forever. So these are some examples that what the approaches of sustainability, how if we maintain sustainability properly, what type of problem can be solved, like global warming can reduce, like this you see that the water pollution is so much there, so that can be reduced. And also that the Miami Beach situation, the sea level is increasing, so that can be controlled. Somewhere the water crisis is there, so that can be controlled also. And there is some air pollution that can be controlled. So these type of things, the main issue is the sustainability, where sometimes is social issues, sometimes is the environmental and economic issue is taken care from the beginning. So this is taken care from the beginning, so industry knows that how to gain more profit. So that's why economic issue is not a big deal, because that time they have these things. But nowadays economic issue is a big issue. So what's the problem? Because you know that the COVID situation is going on. Some industry is totally shut down. So if the total shutdown is there, so how they will earn money? If they cannot get more profit, so their economic situation is also going down. So even though we are thinking that industry is always thinking about the economic matter, not only not for social and environmental, nowadays all 3 points are in very serious situation. So how to take over from this type of situation? So what is our task? Should take care about these three things very carefully, such that the system should go for the sustainable way. So these are some approaches, some like job creation, something job security, something healthy life, increasing more profit or more revenue, or increasing reducing some cost. So for that way, what are the main application of this area is that this way we can make this more sustainable. Like what are the main pillar there? The resource planning, next the recycling, CCS is the carbon capture and the storage area, green logistics, green mobility, CSR, corporate social responsibility, circular economy, renewable energy, and so many things. In between, the more things are going on nowadays is the green logistics, green mobility, green productions. The word with green is going on too much highlighted because of these things, that to save the nature, to make more sustainable supply chain. So let me explain that what is that resource planning things are there. So in the traditional time, every time that new resources or new raw materials are always used. Now think about that. If you use new raw material every time, so production cost will be similar. And now using this sustainable planning or sustainable strategy, that what is that a specific part, that okay, start something that which can be reused again. So reused again means that if you use something reusable product, so then definitely the unit production cost of the product will reduce. So that is the main theme of the resource planning. So just I'm just showing a diagram. Eventually if you go for a traditional production system, so it is sorry, traditional supply chain system, so it is going like this way, that it is going from the manufacturer to the distributor and to the retailer, and finally when the customer will buy, so they will buy from the retailer and then supply chain end. This is generally the forward supply chain. So these things are modified to make the sustainable way. How? Whenever the customer bought the product, like we are just considering suppose some smart mobile phones. So if we are buying smart mobile phone today, so after 2 years, 3 years, 4 years, 5 years we are using, and after that we will buy some new mobile again. But whenever we are buying that new mobile, that time we do not do with this old mobile anything. Very less people are using this type of policy for returning back. Most of the people just ignore this type of smart products anywhere, just throw anywhere in the drawer, anywhere, and they do not bother about this type of things. mobile can be damaged, but there are several things which exist in the mobile which may harmful for the environment and also for us. So what we can do, so just let's collect for those type of products. If we collect these type of products and then go for inspection and several policies, and then some products can be reusable. I'm just giving a very small example for the cold drinks. If you go for cold drinks example, after drinking this one, we just throw it out. So that can be used for again for inspection, recycling, and then reusable material that can be used again. So if that's so, so definitely the source, uh, that means the raw material price will be reduced. So that I'm just structuring through the mathematical way, that initially when we are using the forward supply chain and we are considering with the q item, so total resources has to provide the item alpha q something like this, and from there the manufacturer will produce q item. But whereas nowadays that using the reverse logistics and using that one of concept of the circular economy, so this matter is going on through the reverse logistics. So some part is coming from the reusable material and some part is coming from the resources as a fresh material. So the main benefit of it is that the production price, that means unit production price per product, it is reducing. Now suppose if the recycling is going on and there is no product is going to, that means no, those products which are not going for the reusable material, so those we can use for the remanufacturing and the secondary market we can sell. Just like I'm giving an example for, so some bread factory, if you go for some cake factory or bread factory, so they every day produce a lot of breads or cakes. So people can eat that, but those products which are not sold, what they will do, the second day it cannot be reusable again. So what is that point? So the earlier option is that okay, discard these things. So nowadays what is this going on? So these things of continuously remanufacturing for different products. So those products cannot be eaten by the human being, but that can be made a food for the fish or other animals. So these type of things is can be sold in the secondary market. So that means each of the part of each spare parts of products or any product, so when it will be used by the customer, after that whatever part left, so the leftover part can be again used for some other purposes. This is the main planning for the resource one. So there is that concept for the third party logistics and the fourth party logistics, how to do this thing sustainable way. So please, I just go back to the last slide. Suppose this third, the collection of the EOL product, EOL means that end of life products. So end of life products, who will collect these things? Someone else. It is not the task for the retailer, it is also not task for the manufacturer. So someone else means that this is another party is considered as the third party logistics. What is their task? They inspect and then something recycle and then return back some product to the manufacturer, and something go for remanufacturing and like this. But what is the problem is that there are so many third parties and then it is very confusing that which one is good and which one will do which part. So that's why the new contribution is coming nowadays. That is the fourth party logistics. Now, what is the difference between the third party and fourth party? So that I just highlight here. So those students who are working in this reverse logistics area in the supply chain or the sustainable supply chain, they can easily use the concept of the fourth party logistics, which is a very good concept. That's a combination of different third party together. Means that suppose there are three third party, four third parties working together. So 4PL task is that they will combine, is connected all third party and is centralized by one. So that is the main concept of the fourth party logistics. So those third party logistics, suppose if you go for inspection 1%, say recycling 1%, reusable material separation and non-separation part is another person. So different third party that can be controlled by a single fourth party logistics, and they will control these all third parties. So this is a big concept nowadays going for the research, even though there are very less paper on this area. So this way you can consider about the sustainability of the supply chain for regarding your modeling for research. So what is the benefit of these things that I already explained, that the raw material, that reduction of use of raw material, because we will reduce, because reuse will percentage. But please be careful whenever we are thinking the reuse or something, the reuse or remanufacturing, it should not be so much such that the production rate will very low and remanufacturing or reproduction rate is going so high. So that there is something specific mathematical constraints are there. We should be careful about that matter. This way, we can consider the reduction of waste, the production cost reduction, improvement of the environment, and workplace also. They can get the more benefited, because if you go for fourth party logistics and there are so many third parties, several people will get the job from this side. Next, for the recycling, this part almost all everyone is known that if you go for production, definitely all products are produced perfect, it is impossible. So some products are going for that defective items, so that can be remanufactured or recycled, or the after use the product that I gave the example already, so that can be also the recycled. So just a similar example, that whenever we are just considering the backward logistics, is the backward supply chain, not the forward one. When the retailer is have the so many products they are selling to the customer from different region, please concentrate here that the product is not sold only one region. Suppose you buy mobile from Delhi, it doesn't mean that you will always stay in Delhi and then use the mobile in Delhi. So you may go to Mumbai, you may go to any other state of India, and then there you can use. And after that, whenever you are using the mobile, you may think that this mobile I will not use anymore, so you can discard the mobile there. So means that the product is bought from Delhi, but it was just unused when we are getting the mobile. This is suppose in Mumbai, so it may happen. So matter is that how do you know that how many mobiles you sell, and how do you know that where is the present position of the mobile? So that can be done, so that I will show you after some time, that there are some slides. So how to do this thing, we have done some research also for this. So there is some name, the RFID tag, and through the RFID tag the scanner can detect where is the product. But it doesn't mean that from Delhi to Mumbai they will detect. There is very small range of 100 feet or 100 meters like this. So there are so many tags, so many scanners needed to detect a big area. So everywhere we can check, and this way we can recollect the all products which we sell to customer. And if we recollect the waste, number of waste, the amount of waste will be reduced, and similarly the amount of recycling will be done properly, and this way the environment can be saved also. So these are the things what I say, that the base thing is that the reduce waste, and the next one is the reduce the demand of the fresh raw materials. This is the most important thing, because if you continuously use the fresh raw material, automatically the price will increase. Next important part is the carbon capture and the storage. What is the concept? The concept is about this one, that suppose we are going on so many research. If you go for search in the supply chain management, everyone is going to target that, okay, reduction of the carbon emission. But now can you please tell me that what we will do with that reduction? Means if you reduce carbon emission, if you reduce, then of course it will help the environment. After that, what you will do about this carbon? So this is the biggest story and biggest technology that what is using for a long time. But nowadays this area of research is going too high. What's the concept? The concept is that capturing that carbon, that whatever, suppose you are driving a car, the some carbon is going to be emitted from the silencer, so that from silencer there should be some machine by which the carbon may be captured, and then the fresh air will be emitted outside. So this way, I'm just giving an example for the car only, but if you go for any industry, there is a big size pipe, and then from the pipe is continuously the carbon emission is going there. So this emission, if that carbon can be controlled, that means carbon can be captured, and this carbon, the carbon is totally separated and oxygen should be separated. So this is the process of the carbon capture and the storage policy. And that way the oxygen will go to the environment, it will not anything harm to the society or the environment, and rest carbon can be used for other purposes. So this is the important. Now there is a big confusion or big controversial issue for the zero carbon concept. So that's why I wrote that almost zero carbon. Please be careful that several researchers said that zero carbon, even though I want to say, but problem is that, but human being also made by the carbon. Okay, so zero carbon, frankly speaking, it is almost impossible. So that's why the mathematical way we can say 10 to 0. So 10 to 0 is that almost zero carbon. So that we can do easily. So these are something process that is from the chemical engineering area. So that professors belong to chemical engineering, they can say better than me that how to process is exactly that from the manufacturer they capture these whole gases and then through some storage process they separated this carbon and oxygen totally separated. And what the companies that those are the extracting oil from the soil, so they are using this type of carbon more. Earlier what is going on, so they are using more amount of carbon and more amount of carbon directly they buy and then use it. Nowadays they are trying to use this one, the capturing these things and then they are extracting, so the price of this carbon is going to reduce continuously. So these are the some effect of carbon capture or and carbon storage benefit. Next the point is for the green logistics. So that I said that suppose we are using huge amount of plastic. Now please think that you just reduce the plastic use and then increase the use with some jute product or anything else which is made by the trees. So if you can do that, okay, it's a big problem is there. Suppose I'm giving an example. This is an international conference, I should not say this way, but this is the real story, so that I'm saying. Suppose I always support that, okay, do not use plastic, okay, use the paper cover or paper bag. Okay, I'm carrying with something product and with the paper bag some days, and that time suddenly the raining started, and after that the bag totally gone, so product is on the road, so I have to collect the product from the road, which is very risky because continuously car is coming. So this type of situation may happen. So that's why of course we should use the green product more, but it should be very careful. Or you, there are so many products that which is made by plastics, so we can reduce the uh, use of plastic, but it doesn't mean that total plastic gone. So in such a way that it will be recycled properly such that it will not harmful for the environment. That's the main aim. Green logistics never said don't use plastic. Green logistics said that okay, use the plastic but recycle in such a way that it will not be harmful for the society. So that is the main concept for the green logistics or the transportation. And also similarly that way the storage CCS policy, that carbon storage policy can help to reduce the carbon matters. So earlier we do not bother that how much carbon is emitting. Nowadays we use this improved technology that taking more carbon there and automatically the carbon emission is going to reduce through the green logistics. So these are the something like earlier situation that the traditional transport systems continuously, and nowadays you know that from the government they are trying to make it all the green logistics, so go for green, so zero emission. So this type of policies are continually adopted by the government also, such that the in nature the environment can be saved, and it's ultimately benefit for us. It's not that the anyone's personal benefit, ultimately benefit for the people. So similarly, the another biggest research area is going on the green mobility. So green mobility also is the similar concept like the almost zero carbon or the go green. So the fuel, what is the fuel is using? So except using petrol, diesel like this, try to use more uh, biofuel or something like this, where the chances of the carbon emission or other emissions which is harmful for the environment, so that should be reduced. So that's why these are the some examples that where this type of advertisement continuously is going on, go for the green mobility. And the next one is that the CSR, the corporate social responsibility. What is this one? That the when the company is going on with more profit, so they are trying to their development of the business. So when they will develop, automatically they need more people. When they will need more people, automatically they will hire. So as a benefit, so several people will get the job. So this is the benefit of the social matters. Okay, so last time is that during the traditional supply chain we do not bother about this type of CSR, corporate social responsibility, but nowadays that some part is coming from this side and some part from the traditional ways. So that's why there is always a big benefit from the society also, And similarly, for the environmental also case is that several tree plantation is going on such that the emission can be reduced, global warming can be reduced, different that orphanage is forming through the NGOs, several disaster donations are going on just to save, to support the government and to support the people also. So these are the responsibility are doing by the uh, supply chain, that means the industries, and these are the biggest research area what is going on for the supply chain to make them more sustainable. So this I explained already that the CSR benefits. Next, the concept is the circular economy. The most important is that the concept of the primary channel, that from the waste, if you think something is the waste from the primary channel in the supply chain, it should be used in the secondary channel. That's the main concept for the circular economy, that using very less resource, how to get profit. Suppose if you have $10,000 investment, so you can go for okay $20,000 profit. But think about that. I am not investing anything, and then I'm getting $10,000 profit. Can you do that? If you can do, that's the concept of the circular economy. So use your brain how to do this way. So that's the concept of the circular economy. So I'm just giving an example. Suppose from the retailers that some product is bought by the customer, this is waste total, and this waste collection from the waste, if we can gain some energy, and that energy can be used for our house purposes, so that is the biggest benefit for that one, because this is totally waste, you just throw it out. But from that processing of this waste, if you get something a little bit energy, at least one day you can use your fan or a bulb or the air conditioner, you can use this type of energy. So that is enough, at least you can save something. So that is the concept of the circular economy, that without throwing out, can you think once or twice that you can reuse it again or not? Any part of it, can you reuse it again or not? So that's the main concept of the circular economy part. So these are the benefits, different one. Next, the renewable energy concept. So target is that anyhow the energy should be used or reused in such a way that the renewable energy should be used more. So that's why the solar system and different types of research is going on to use this type of bioenergy, biofuel energy, or different types of renewable energy, such that the general, when suppose in a factory or the industry, if you go to the production house, you can check there are so many lights, and if we are considering only that LED in the house to save the wattage amount of energy consumption, but they are using so much powerful bulb such that the light should be proper, because otherwise the production will be disturbed. But that light source is from the natural energy. So how to do this thing? So okay, if they will use something solar panel, so at least 1 month or 1 day or 1 week at least, the solar panel, that energy can be utilized. So then it will be a big benefit to save the natural energy, and that will be the renewable energy will be more beneficial, and automatically the industry will get more benefited in the sustainable way. And that's why the government is continuously supporting to do this type of things. So there are big things are going on to support this type of, if any family want to change, or any industry want to change their energy system to the renewable energy, so government is also supporting for do this type of things. So I'm just giving an example that initially if you have alpha A percentage and total is F, so now you can take, okay, alpha A percentage is from, alpha percentage is coming from the natural energy which you are paying every day, and then 1 minus alpha you can use that for the just using the solar panel. You do not have to do anything, but initial setup is needed to buy the solar panel setup, and then from there you can the charge, that means the energy will be saved in the battery, and then using that one you can use in your home. So your amount of electric bill every month what you have to pay, it automatically will reduce. So that is the another way of renewable energies. This is something example. Now what is I'm explaining, that's the way of mathematical modeling what we have done, and how to extend this way in the sustainable modeling area. So this research what we have done here, the recovery channel selection in a hybrid manufacturing remanufacturing production model with RFID and product quality. What is the concept behind it? That is the same concept I'm saying till now, that the uh, smart product, if you are considering the smart product, and this smart product suppose just I'm giving the same example mobile, that if you put in the drawer and after 5 years you didn't know where the mobile is, this how to detect this type of mobile, how to detect this type of smartphones or anything smart products. So there, that I said already, that the RFID tag is there. So these type of things you can use to save the nature, because this radiation from the mobile is huge. So that similarly, I'm just giving the example of mobile. It doesn't mean that the radiation from TV, radiation from the computer is less. Okay, so everywhere the electronic gadgets will provide so much radiation. So that can be controlled if there is some RFID tag, and using the RFID scanner, you can search immediately. And what is the main task? Just return back, or the you just resell that one in the secondary market, so they will reuse it again, such that it will stop at least the environmental disturbance or environmental problems due to this type of emissions. So what is that, the blue color part, what I'm just putting for every slide. So this way we can do more better, that for further studies, that for further research, those students who are working on that area. So this is the last part, is the extension, how to extend this way. Because the main benefit of RFID tag is that we can reuse it again. So just if you have a mobile, there is RFID tag, just open it and you can put in another RFID tag, RFID that mobile again, so that the same RFID tag can be reused again. That's why this way we can save the waste also, we can save the environment also, we can save the money also, because the RFID tag can be reusable. Then another research area what we have done there is the sustainable ordering policies. So how to do this? Suppose you can order as many times as you need, there will be no restriction, okay, because you have money, so you can order to the shop anywhere, anytime. But can you do it sustainability? With sustainability means that three things you should take care. That means your internet, when you are ordering through email, internet use should be less, so your time should be reduced. That means using the manpower, you are thinking, okay, 2 minutes ordering through the email, it doesn't matter, but time is money, so you should concentrate about the time, how much you are using on internet to order the product. So this type of things you should consider. So that we have done already in the paper. But the matter is that, if is it possible that the sustainable way reduction of the deterioration, that we have considered the deteriorated products here. So this is not done yet. So this is another story of research, so you can think this way. The next point is that what we are doing, that suppose if we want to buy, it's not for us, it's for the industry. Suppose if you want to buy that any product, the raw material, there are several suppliers. So now how do you decide that which supplier is the most perfect one? So supplier selection problem is the biggest problem, because you choose some supplier who may not supply in proper time. So if the proper time is not done, so all things will be delayed, all the schedule will be changed, and that's why you will face huge amount of loss. So that's why this type of supply selection we have done already. But what is that concept, that the returnable products, they are the replace of the third parties, selection of the third parties is not done anywhere till now. So that is another big area where the sustainable things can be used easily. Next, for another research where we have done, that the smart optimum flows of cash, cash flow within a within a smart production scene under the logistics system we have considered. So we found that what is the best sustainable way for the net present value of product. Like today, one product price is suppose $10, or say just go for Indian currency. So suppose 100 rupees is the price, but if you go for after 10 years, the price may be so high. So how to decide this way, that after 10 years what should be the price, and so much like this. So this way we explain on this paper, on this research area. But the main issue is that the sustainable approach of the profit is confirmed with the positive the net present value, NPV, through the product. But this is not the considered is done for the online and offline system, because this is just a price is considered and then the task done. But the important is that nowadays, due to this COVID situation, everyone understand that the concept of the online and offline product, that we can order online, the product can come to your home directly through the home delivery concept. So these things we never think about this time when we have done this one, because this is the last years we published this, last year this published this paper, and that time there is no COVID matter. So we can rethink about this direction of this type of papers, so then make the sustainable way of selling. And this one we have done for the lean manufacturing area, for the multi-stage production system. Even though there is some uncertainty, we have done with these things, but the main concept is that reworking procedure is considered as the deterministic, but it depends totally on the random situation. If the if the sorry if the product will be, that means the returnable product, of course it's a random variable, you cannot assure that whole product you are selling. So 2%, 3%, 5% is fixed to return back. So that is the main issue here, that it is a random variable. So based on that, the remanufacturing process should be random variable. That is not done yet. Even I didn't do, and that is also not done. So that is another research area who are working on this, so they can think about that one. The next, what I said just right now, so that online and offline economic policy is discussed here within the closed loop supply chain. This is okay, but the main point is that the concept of the circular economy, that means amount of product amount, that means the resources amount using should be less, and the profit should be more. Just like I'm just giving an example, what you are doing for buying a product if you go for offline. So suppose from home you just take a card, or suppose your card, so you take your card and then go to the shop, you invest your time to search the product, that which one is you like most, and then take the product and return back to your home. So ultimately what is the price of the product? Your time, that means money for your time, plus the transportation charge, plus that from where when you invest the time on the shop, plus invest the time in the room when you decide the product. Now if you go for the offline, this is offline, and if you go for the online, what is the benefit? You decided the product from home, you invest the time on the internet and just order, the product is come to your home. So the benefit is that the transportation cost you do not have to pay. Due to your transportation there is some carbon emission that can be saved. So these things are saved through the online system if you order something online. So that is the main concept of the circular economy, that resources, use of resources should be less, profit should be more. So that is not considered anywhere, so that you can consider for this one. And that is what I'm saying, that the even though environmental and economic assessment we have done, but this is not done for the anything for the social issues. So if we consider the social issues, it can be done again for more sustainable options. Then this research what we have done, that the how the sustainable investment, suppose if you are going for a business, how much do you invest for it, how to decide this one. So we are just considering a multi-stage production system, and that for multi-stage production system, how to get the sustainable investment, that we will explain here. But the main issue is that when we are going for the investment, this is only sustainable issues, but whole system, does it make a sustainable investment for the quality improvement? That we didn't do, because quality improvement is the biggest issue. Suppose the customer, we means the customer's demand to the industry is always too high. What type of things are there? That we need, okay, we need a computer who can do everything for me. But suppose industry will make this type of computer. Now the price of the computer, if it is $1,000 right now, so the price of the computer increases of $10,000. Then customer said, okay, I cannot pay this $10,000. So what does it mean? It means that even though it is his demand that we need this type of computer system, but they don't want to pay. So their quality is improved, but customer doesn't want to pay this amount of money. So that's why the price should be in such a way, or in such a sustainable way, such the quality also be improved, also price is not also increased. So this is the biggest relation between the quality improvement and the pricing of product. So that is not done for this way. So that anyone can do that for the further research. So another one for the economic viewpoint, so we are calculating always the optimal uh, mm, optimum production quantity within some production house, but there is something matter, that the defective items, so that is going for the random. So if the defective production is going for random process, the inspection, how to inspect the product, that product is going by the inspection is going by the human being. So we have introduced with one of my scholar. He is now a postdoc in Korea now. So with him, so what we have proved that automation policy is the biggest thing, and that is the concept for the automated inspection, nothing big thing. So automated inspection can be done in such a way such that the human cannot be used for this inspection, and this way the benefit is that the product should be inspected properly. So automation policy we already introduced, but sustainable automation is not done yet. So because automation policy is just, we have published the paper last year. So this paper is not volume number, page number duplicate. So this is just right now, you can say, the recent paper. So if anyone is interested for the sustainable automation policy, so is always welcome to do that. And this area we can make the sustainable automation policy easily, because it is possible, and also it is needed to save the inspection error by the human being. Next, let me explain about the environmental viewpoint. So some area of research what we have done, that reduction of the combined effect of the reduction of carbon emissions. But the main problem is that whatever we have decided the sustainable supply chain, we didn't follow that the CSR nowadays, which is most important, corporate social responsibility and the job creation. Because nowadays, you know that due to COVID, several people are jobless. So how to create the job through this way? So that can be done with this type of research. That, and this paper really accepted, but published, will be published in next year, 2021. So anyone can consider the CSR concept or the job creation, that through this type of supply chain, how the sustainability issues for the social matter will be more highlighted for creating the job for the people who lose the job. So that can be done easily. The next, another one, the research area, which one we have considered some production model. And there we have considered the green investment. Green investment, that investment in such a way that the amount of that means the carbon emission and other things can be controlled. But after the investment, of course, the green production, the emission is reduced. But emission, after reduction of emission, what we will do by this carbon? So that we can use the CCS policy, that the carbon storage policy, which can be used by the oil companies to take their oils from the soil, from the ground. So that is not also done. So we can consider that one for the another sustainable direction. And that is very recent. It is not published yet. Just the online, we are just correcting the proofs, that paper. What we have done, that we have research on so many things on the biofuel. Now what we are planning to concentrate on the animal fat. Suppose if you go for any shop where the animal is cut that through some machines, or they are cutting by themselves, so there are so many fats are there. What the fat, the people will not eat so much fat, so what the fat they will do, so that fat can be utilized for the biodiesel, and it can be a big benefit for this one, for the resources, for the biofuel. So these type of things can be done. So this we are doing, how to do this type of things. The next, for the environmental one, that is with Professor Esar Singh and one of his student, with Professor Neha. So this paper is published this year. What we have done, that we want to reduce the waste management. So how to do this? So how much that means remanufacturing can be done. Suppose if we think, okay, we are understanding remanufacturing so much, so that means, okay, stop production and consider all our remanufacturing. This is not possible. So you have to consider both the way parallel. That means production and the remanufacturing. So if you consider production and remanufacturing parallelly, how much maximum you can go for remanufacturing and how much maximum you can go for production. So there should be different from the different products. So that we have done in this way. But problem is that we have done, this is the only one direction of the waste management. We didn't think about the other direction of the social issues, like job creativity or something else. So that area we can extend for this paper again. The next one is that we are considering that the reduction of waste and also the reduction of the consumed energy, how much we are using in a day. So that we can think. But the main issue for this biofuel production, what we have done during the main source of carbon emission is that one is the production side and another is transportation side. So transportation side is totally ignored in this paper. So we just consider transportation, but this is not reduce the carbon emission. So that area of big area of carbon area reduction of the transportation side we can do for further for this environmental viewpoints such that it can be make it more sustainable way. And suppose if there is already disaster, that means due to some earthquake or something like this, so then how do you manage to waste huge amount of waste? So this type of study we have done, and this is the only waste we are considering the waste reduction policy. But as I said that there are three pillar economic concept also, the of course the environmental issue is there and then social issue is there. So if we introduce the social issue is there also, so that is another area of the large scale disaster, because when the disaster is coming they are not saying okay I'm a small, I'm a large, okay, so it may happen anytime. So how to manage this type of situation, so that is the another research area for this one. So the second one, that another thing we are recommending for the um, resource as a next generation energy for the these things. So that thing when we are doing with this thing, so we are going for more research for how should we use the energy more, and that energy should be for the reusable energy or renewable energy, not the exact the natural energy we are using want to use every time. So that is one of the how to manage this thing. So that is the another research is here. So the main issue is here that we are considering the sustainability here, but the main point is that the considering sustainability and considering sustainability for a long time is coming problem because of the awareness of the people and awareness of the employee who are using this type of things. So that can be done for that. That means repeating, uh, like we are giving this webinar, several people can get the information from here, so they can attend sometime like this conference or webinar, something like this, and they can be trained properly such that the next generation energy can be more fruitful for this one. And like the Delhi situation, that in the sometime the air situation is too much disturbing, that the pollution level is go so high, so that how to manage this type of situation. So I have the data something from Korea, so I do not have the data from the Delhi, so I cannot do this from there. So what I have the data from here, we just check that what are the detection point, that when the alarming or the things should be done, so that we have studied something here. So what we can extend if we have the data, if anyone is related in that area, or if anyone want to go for research and he has the data from the Delhi side, I know only for Delhi's matter, but all other I don't have the information. So if anyone has the data, so we know how to do these things. So detection point, and when it is going serious, how to control this type of things. So we can collaborate and we can go for this further research of this area, but this area is specifically for the data one. So if you have data, if you we know the process, but if you have real data, then only we can process this type of things. So next point is the social viewpoint. So already I said that the online and offline business policy with something, this we have published with some paper that is in the electric power distribution system. That means using that what the electric every day we are using, that same one. So what do I want to do, that the same one we want to do, we accept the electricity within, not accept the all, some percentage of electricity and some percentage from the renewable energy. So that can be done through the social point of view, that some people can involved for this one, and they that can be create more jobs for that one. The next one is that the we when we are going for the industry, we do not bother about the that who are the worker, what the stress level. So we should think about that, because they are also human, that the security of their job, their stress level. So that we have done for some industry, automobile part industry. So these type of things we can develop continuously for different research, such that this type of things can be can be done in the sustainable way. Another thing is that the matter of the blood matters, that when suppose please think that when there are so many hospitals every day, that there is a blood bank for every hospital, so several bloods are needed for this one. So blood, when some blood generally 5 to 7 days are using this blood, and then after 5 to 7 days that whole blood gone. So that means even though there are so much blood, but it is not usable. So how to control this type of waste? That means in a hospital, so much blood is there, even though it is not using and going to waste. The other hospital, there is very less amount of waste, less amount of blood, and that they need so much blood. So how to make a in proper way of transportation such that this blood product, or specifically we have done for this one is the blood product, this way how to save this human being for this one. So that is the HSCM stands for your health supply chain management, healthcare. So that healthcare supply chain management, how to control this type of things. So that we have done in some social viewpoint. Another one we have done on the similar area, healthcare supply chain. So the main issue is there also we concept the energy consumption matter, but we cannot make till now all this way of economical and also the social and also the uh, that environmental together. So that's why how to make this type of healthcare supply chain for all way in the sustainable way. So that is a big research area nowadays going on. And the last one, the suggestion is that suppose if so many people come together and then you have to decide that okay, who is the best human workers for your industry. So there you can decide that three different ways: are skilled, semi-skilled, or unskilled. So which people will work for which way, and how their unskilled laborers can be considered for skilled labor with so many trainings, or the different say trainings they can attain after 1 year or 2 year. Similarly, semi-skilled people, how they can be made for the skilled mode. So these type of things should be done. This we have done for the industry only, that for the smart industry, smart manufacturing area. So this for the supply chain we can do this way, biggest area of this one researcher. For anyone can consider this quality of the risk, that the labor which we are considering for this type of things. So that's all about this, whatever my recommendation for this area for further study for the researcher on this field. And these are the references, and thank you. So if you have any questions, you can ask.
Any question? If anyone has any question, please share your question in chat box also.
Okay, let me stop sharing, so then I can.
Thank you very much, sir.
Thank you very much. Most welcome.
It's very important lecture for the participants and those who are working in industry and working in industrial engineering. So I would like to thank again Dr. Vishwajit Sarkar sir. He tells us resource planning, recycling is important, and CSR, benefits of circular economy. And he also given some examples of renewable energy, alpha F and 1 minus alpha F. And we have three important aspects of this study: mathematical modeling, economic viewpoint, environmental viewpoint, and social viewpoint. So this is very important, and this is new research in terms of the industrial engineering participants. So I would like to thank again.
Sir, this is not only industrial engineering, because my main base area is mathematics.
Yeah,
My
yeah.
all degree is also in mathematics. So how the mathematical way that we can work, that I want to show. And why I put this all my papers there, so such that they can get the reference immediately, that how to do this thing.
Okay, okay, okay.
So that is the main benefit.
Okay, okay, okay. Okay, sir. Thank you. Thank you.
Thank you very much, sir.
Thank you. Thank you again, sir. So now next speaker is Dr. Dhiman. He is just visible here. Dr. Dhiman, are you listening me? Please unmute your.
Yes, sir. Yes, sir. You're
Yes,
audible.
yes, yes. Next speaker is Dr. Neeraj Dipan, Associate Professor and Head Department of Mathematics, Graphic Era Hill University, Dehradun. He will talk on the topic numerical solutions of partial differential equations. I know personally Dr. Dhiman. He is well in mathematics. He is head of the Department of Mathematics, Graphic Era Hill University. He has 9 years experience, and he is all working in this field, curriculum development, for BSc level and MSc level, convener of Board of Studies of Mathematics, and he also got some awards appreciated for the coordination committee of 9th Uttarakhand State Science and Technology Congress 2014-15, certificate of appreciation for academic and non-academic work in Devbhoomi Institute of Technology, Dehradun, and he has more than 24 papers published in international journals of repute, and I have seen some special responsibilities as a convener in National Workshop on Advanced Numerical Techniques and its Applications, member of Organizing Committee in international conferences on mathematical techniques and engineering applications, member of Organizing Committee of 9th Uttarakhand State Science and Technology Congress. He also write two books, Linear 3D Thermal Stability and of a Viscous Fluid in Cubical Cavity and Optimal uh, replacement policies for deterioration items under inflation. And he is also member of some committees and membership of Institute of Advanced Scientific Research, membership of International Association of Engineers. So I would like to invite Dr. Dhiman for the presentation or for the talk on the topic of numerical solution of partial differential equations.
Thank you, sir. First of all, I would like to thank all the organizing committee member, Dr. Padalia, Dr. Vivek, and Dr. AP Singh for giving me this opportunity. And my topic on today presentation is the numerical solution of partial differential equation, in in which I will just explain the Crank-Nicolson as well as the collocation technique. Uh, Thank you, sir. First of all, I would like to thank all the organizing committee member, Dr. Padalia, Dr. Vivek, and Dr. AP Singh for providing me this opportunity to express the few things related to the solution of partial differential equation. In this talk, I will just give the introduction from the partial differential equation to the solution of partial differential equation by using Crank-Nicolson as well as the collocation technique. Padalia sir, is my screen is visible?
No, sir. First open your PPT, then press share screen button.
Padalia sir?
Yes, sir.
Sir, is my PPT is visible?
No, sir.
Sir, first open your PPT and then press the share screen option. Yes, sir. Now your
Yes,
PPT are visible.
yes, now visible, sir. Dr. Dhiman, please continue, sir.
Yes, sir. Yes, sir. Just is it
Yes,
okay, sir?
okay. Yes.
Okay. So the topic is the solution of partial differential equation by numerical technique. Actually, a numerical technique.
Sir, please again try.
Sir, some technical issues there. Actually, when you sharing your screen, please unmute your sound, sir.
Try again, sir.
Sir,
Sir, unmute your mic first.
Yes.
sir, now Padalia sir, is it visible and as well as audible?
Screen is not visible. Your video is visible. Try again, sir.
Yes. Just a second, sir.
सर स्क्रीन शेयर करो तब दिखेगा। दारिया जी स्क्रीन शेयर करें।
वो सर धीमान सर को दिया है हमने कमांड।
सर ये स्क्रीन मैंने शेयर की है।
नाउ लेट अस स्टार्ट। यहीं से स्टार्ट कर दीजिए।
ओके सर। So sir, the numerical and audible also.
Yes.
Yeah. The numerical solution play a widely great role in the solution of the partial differential equation and in the model whose exact solution is not available. So we just approximate the solution by using the numerical techniques. A partial differential equation PD is used in the modeling as well as in the other things. What is partial differential equation? An equation which is involve unknown function as well as its partial derivatives. Like u is the main function and it is depending upon the x and y and x and t. X and t are independent variables. These are the notations. Just it is just a common. Everyone knows that double derivative of u is represented by uxx with respect to uxt represented by this. The order of the partial differential equation is always the highest order derivatives. Classification, there is two types, linear and non-linear partial differential equation. In the partial differential equation, if the dependent variable and its derivatives is having power more than one or their product or their series, then the equation is considered as a non-linear partial differential equation like this. Because of these terms, we will say it is a non-linear partial differential equation. And the solution of partial differential equation there. We can represent the solution of partial differential equation in the three form, either for taking one variable as a constant, independent variable, and we will plot the curve of the solution for other variable like this. Suppose the t is constant, then this is the u solution and this is the domain of x. Then at time t, 1 time is equal to 2 as well as time is equal to 3, we are having these three graphs. For three-dimensional, suppose we are representing the heat, temperature of the heat with respect to x and t, then one dimension is representing the solution, second is with respect to x, and third with respect to the time. That is according to the surface plot. And third, numerically in a grid point way. In one direction we will consider as a x, in one direction we will consider as a time, and we will have a solution at different grid node. We will just break the space and time domain in a equal or unequal grids. Heat equation, in a heat equation, this is just the heat equation where T is the main function, time, temperature, depending upon the surface X and T. This is one dimensional heat equation, like we consider as a rod of both the edge. We have considered at 0 degree centigrade. Then there should be a temperature change because at the initial, the temperature of the rod will be considered sometimes like a room temperature. At rod temperature is sin pi x at time t. Temperature of the rod is this, and this is the boundary condition. At boundary, if the length of the rod is considered as a 1 unit, then at the starting point and at the end point, the boundary is 0. Temperature is considered as a 0. Then the graph of the temperature is accordingly this. This is the direction of temperature and this is the direction of x, 0 to 1 in 0 to 1 direction. First, this is the temperature with this temperature at different time. Most commonly used partial differential equation in modeling and science field are Laplace equation, heat equation, and wave equation. This is just the basic equation also which MSc and BSc student gone through. A Laplace equation 3-dimensional is this, where A Laplace equation is describe the steady state distribution of heat in body as well as describe the steady state distribution of electric charge in the body. One equation is representing in the different model. This is the heat equation, 3D heat equation. Simpler heat equation, this is one dimensional heat equation. Wave equation for 3 dimensional. Hello. Classification of partial differential equation. In this, the classification of partial differential equation is required. Why? Because a linear second order partial differential equation are the important set of the equation that are used to model many systems in many different fields, science and engineering. Why we require a classification? Each category related to the specific engineering problem, as well as different approach are used to solve these categories like elliptic, parabolic and hyperbolic. These are the classification of the partial differential equation. If this is the partial differential equation where a, b and c are the function of x and y, where d is the function of x, y, u and its derivatives, then b square minus 4ac less than 0 is the classification of elliptic, b square minus 4ac is 0 parabolic, b square minus 4ac greater than 0 is hyperbolic. Linear second order partial differential equation, suppose this is the Laplace equation. This is the Laplace equation of 2 dimensional, and this satisfies b square minus 4ac less than 0 elliptic. So one possible solution one possible solution, not all qualification. Now the boundary condition of the PDEs. Every PDE should satisfy some boundary condition because that are the limitation. So according to the limitation, according to the model limitation, we will solve it. Like if we are going to consider the heat equation, 1D heat equation or 2D heat equation, then there should be a limitation. Like this is the equation of the 1D heat equation. Then at the starting temperature is 0, at the ending point temperature is 0, and at time t initial condition is sin pi x. That means the curve of the rod is representing like this in a sine curve. Solution. Method of partial differential. Analytical solution are possible for simple and special cases only. To make use of nature of the equation, different methods are used to solve different class of partial differential equation like elliptic, parabolic, hyperbolic. We have different approach which will give more accuracy and convenient. The method discussed here is finite difference, parabolic equations. These are the heat is a parabolic equation. Then finite difference. What is finite difference? It is as mentioned as the name, finite difference. We are considering in a x direction a equal grid partition as well as in a time direction an equal grid partition. Like the length of the rod, if the length of the rod is 0 to 5, then we will have h is equal to 1 in x direction. That means the each and every partition in the rod is having the same length, that is 1. Then it will go finite difference, and in this finite difference x is represented by the loop of iota I, and in time direction we will consider as a j. That means if the solution, this is at t0, this is at initial condition, then for t1, then for t2, and then for t3 third, and t4 fourth temperature, the value of the in a k, the difference in time is k, equal interval is k, and equal interval in x is represented by h. And if we are going to run the loop in a program, then the h is the interval in x is represented by I, and interval in j represented for the time. Finite difference method, by replacing the derivative by finite difference method. Replacing a derivative means this is right now, if you gone through with the electric or computer system knowledge, computer knowledge, this is the analog signal. Like we can consider as this is the analog. This is in this form solution, or derivative del square t by del x square will be considered as analog. But to convert this into computer system, we require a digital platform. So this process is called a discretization also. So double derivative, by using finite difference, we will convert double derivative either in this form, and this is for the double derivative, or for the single derivative forward difference. This is by the center difference. By forward difference, we will have a single derivative del t by del t is equal to this, where j is representing the time, j plus 1 minus j, and I is representing the grid of space x. In a center difference, it is for double derivative is I minus 1 grid, previous grid, center grid, and next grid, and at time j upon h square. Solution of heat equation. Two solution of the parabolic equation, heat equation will be presented. Explicit method and Crank-Nicolson method. There is some advantage of explicit method as well as there is some advantage of Crank-Nicolson method. In explicit method, what do we have? This is the heat equation. Then first derivative with respect to t is changed by center difference, forward difference, t plus k time minus t upon k. K is the interval in time. And for double derivative, we have this term. Now simplifying it, and we will calculate the t plus 1 next iteration in terms of previous iteration. Like this is the main equation. This will be considered as the main equation, where if t is equal to 0, we will have, and k is equal to 1, then we will have t at different grade at 1, solution in terms of t at different grade 0 initial values. That means we are using the initial values, but we are getting the next solution. Like the previous, we have distributed the grid. If this is the grid, we are using this t is equal to 0 and getting the value of t is equal to 1 by this equation A. Now in an explicit method, we are using the previous 3 points, previous 3 grid points to calculate the solution of the next point. Like this, t plus k in terms of t, and the grid x minus h, x as well as x plus h. But there is a convergency required, convergency stability. This is also a important part in numerical technique, because if the program is running for the limited domain, it should be not considered as a right, because when we increase the number of grid or increase the domain, there is a problem. So the method should satisfy the convergency and the stability of the problem. So in this explicit, error is increased when the lambda should be less than equal to 1, and lambda is the difference of k, that means time interval upon the space interval square. Lambda should be less than 1/2 or equal to, then the method is convergent or stable. Otherwise our method will give the wrong result when we increase the loops of calculating the problem. Convergency, a solution converges means that the solution obtained using the finite difference method approach to the true solution, that means maximum approach to the exact solution, as the step delta x, that is h, and delta t, that is k, approach to 0. That means as we decreasing the number of partition size tends to 0, that means h is as much as small, we will get accurate as the k is as much as small. Stability, an algorithm is stable if the error at each stage, means each interval, like when we are calculating t for x, t plus k, and next interval for previous interval for x, t. Computational are not magnified as the computational process, means the error is not increasing by the increasing the loop or increasing the iteration, then it is stable. If the iteration is in, while the error is increasing with increasing the iteration, there will be a system unstable. So it will go to the wrong solution. It will not converge to the exact solution. Again, this is the heat equation with the same condition. This is the heat equation with the boundary condition, as well as this is the initial condition. H and K is considered as this, then lambda is equal to 4. Then this is the process how we are calculating the next grid point. This is the initial value, and these are the boundary conditions of the given problem. It is always considered as a 0. This is the main equation, your equation A, by using the finite difference formula, and you are replacing t as a 0. When you replace t is equal to 0, you will get, when you replace t is equal to 0, you get the solution for u x k, that is, this is the interval is k, interval gap is a k, so you will get the solution at this. When you replace the value of t as 0.25, you will get the solution at this point. So previous points are used to get the next point by iteration, like this. This is the x, h and k is considered as a 0.25. So this is for the next, this value. This is 0.25, this is 0.5, 0.75, and 1 in x direction. And this is time 0.25, 0.5, 0.75, and 1 in time direction. So we will get the temperature. Similarly, a remark that the h, lambda is 1 minus lambda is equal to -7, and it is equal to 0.4. It is equal to 0.4, which is less than equal to 1/2. So the method is convergent. Now the Crank-Nicolson, the method involved in a Crank-Nicolson method. The method involves solving the tridiagonal system. Tridiagonal system means a matrix in which only the diagonal element exists to the pivot element as well as left side and right side elements. Then it is called tridiagonal system. Linear equation method are stable and no magnification of error. We can use large K and H in compared to the explicit method. In explicit method, we have a condition that lambda should be less than equal to 1/2. To satisfy this condition, the H and K is always towards tends to 0 or the small. But in Crank-Nicolson method, the limitation is not. We can have H and K as much as large. In Crank-Nicolson, dividing the interval x into the subinterval with h. Same process as we discussed in the explicit method, dividing the interval time t into the subinterval of k, then replacing the first and second derivative partially with the backward and center difference formula. Like this. This is the time derivative. We are replacing it with backward and center difference formula. Then we will have, because we are using the backward and center difference formula, then we have, because of that, we have time at t as well as at time t minus k, because we are having a time t minus k. So in an implicit, we are using these term, initial term, to get the value of t minus k. So the equation which we get is this. This is also represented in a I minus 1 is a loop representing the x grid x minus 1. This is for the grid x, and this is for the grid x plus 1. And at time t, at time t and t minus 1. Now if we fix j is equal to 1, we get the value of u10. U10 means the first grid at initial. This will be the u10. Then the second grid, this will be the u20. This will be u30 initially, because this is t0. Then we are using these values u10, u20 to calculate the value of next interval, that is at t is equal to 1. When we are going to calculate t is equal to 1, that is these values are unknown. We have to find out these values. By using these 4 equations, we get the system like this. Unknown values are u11, if it is t0, then it is t1. Then the unknown values are over here. In next iteration, we are getting the unknown values of u11, u21, u31, u41 for the value of using the previous iteration u10, u20, u30 and u40. We are using the previous values. Now this is the system of Ax equal to b, system of linear equation, which is normally solved in a MATLAB, or if you are using the C programming, then it will be a little bit tough to calculate, because you have to give the input, that number of rows, number of column, as well as these values are 0. Only the tridiagonal system is exist. Beyond the tridiagonal values are 0. So you have to give the command. But in a MATLAB, if you defined a11 is equal to 1 plus 2 lambda, then it is stored. A11 1 plus 2 lambda will be stored easily. You have to define A12 is equal to minus lambda. This value is also stored, and remaining all values will be considered as a 0 by default. But you have to define the dimension, like you have to define that this is the 4 is equal to 1 plus 2 lambda. Then these defined value will be considered as given, and all the remaining value will be 0 in MATLAB. But in C program, you have to mention the zeros, that remaining are 0, and these value will be changed accordingly. So by this system, you can solve this system by using Gauss elimination or Gauss elimination partial pivoting, and you will get the value of next iteration, these unknowns. The solution of tridiagonal system, this is the same solution. Now we are shift to j is equal to 2, then the t is equal to 0 to we are shifting, then t is equal to 1, and we are calculating for the value of t is equal to 2. We are calculating for the t is equal to 2 using the value of t is equal to 1. These values are using t is equal to 1 at time 1, and calculating the value for t is equal to 2. This is u02. I know this is at the time interval t2, but this is at the boundary, and boundary condition is always given. This value is for the boundary, and boundary condition is given. So this system is again converted into system of linear equation. You will solve and you will get the next solution. and the process will continue and you will get the solution accordingly. These are the process. So the Crank-Nicolson method is just same, but what is the difference between explicit and Crank-Nicolson? One need to select a small k h, and the computational per points are very small, but many points are needed. Because there is many points are needed in computational, so sometimes the computational system will take a large time or more time to calculate the solution. But in Crank-Nicolson require the solution of tridiagonal system and stable system. Crank-Nicolson is stable for large value of k and h. This is the advantage of Crank-Nicolson. Now this is the collocation technique. The Crank-Nicolson is outdated. Right now it is not using in a research. This is the main topic when we are going to start for the collocation. Now in this collocation I am considering a one RL equation, that is regularized long wave equation, solution of regularized long wave equation by using collocation technique and B-spline function. This is the equation. This is the partial differential equation. Which solution we are going to find out. These are the boundaries. These are the boundary condition, Dirichlet boundary condition, and this is the Newman boundary condition, and this is initial condition. So ut is just the del u by del t with respect to time. These are the nonlinear terms, and mu and u are the positive parameter. Subscript x and t denote the differentiation. Fx is localized disturbance inside the considered interval be chosen later. It will be fz is depending upon the model and the disturbance we will choose accordingly. Existence and the uniqueness of this problem is given by this reference, Bond JL and Perut P in 1993. So this is the equation. If because I am turning my slides, so if you note it down, then it will be better if you noted down the main equation as well as the boundary condition and Newman condition and initial condition. These conditions are required to solve the solution. Now by collocation method, again the process is same in numerical technique. If you are finding the partial solution of partial differential equation, you have to discretize the system and break the domain in a grid. Now in this method we consider the grid in the time as well as in the space. This is in the space. We are dividing the space A and B in equal interval of x0 first grid, x1 till xm last grid, and a time interval 0 to b. This is 0 to capital T, 0 to t, from t0, t1, tn till tn. So capital M is for x and capital N is for time, where I is for x and j is representing for the time. To solve the problem, we assume that u, the solution of the problem, is in this form. We assume that the solution, because I am using a collocation with cubic collocation. This is cubic B-spline. So cubic B-spline has a limitation to solve the second order differential equation. Up to second order differential equation is a space. So by using cubic B-spline, we have to assume that the solution is as equation A. You can note it down, equation A, where the solution is summation in the term of summation L I minus 1 to I plus 1 for C L and Q L, where C is a time quantity and Q is the B-spline curve, B-spline function formed on a basis 0 to 1. This is the cubic B-spline quantity, which is this. This is the cubic B-spline function defined over here. Q is this, and by differentiating this cubic B-spline function, by differentiating this cubic B-spline function, we get the equation B. For function U, we have this Ci minus 1 node plus 4 Ci plus Ci plus 1, we get the solution. Now, if you assume that you have the value of C, if you know the value of C, then you have the solution U. So we are targeting it to find the value of C because Q is defined over here. This is Q. We have the value of Q in a space domain. We just have to calculate the quantity of time. That means C. If we have C, we can have first derivative. If we have C, we can have second derivative. For the same C, we just multiply the C I minus 1 with minus 3, Ci plus 1 with 3, and sum them. We will get the second derivative dividing by the h. Dividing by the h square, we will get the second derivative. So equation A and B is required to be remembered to understand the method. Now, because the summation is start from minus 1, 0, 1, 2 till the m plus 1. That means we have extra nodes minus 1 and m plus 1. To eliminate these extra nodes, we use boundary condition. This is the C minus 1 and Cm plus 1, which we have to calculate, we have to solve by using the given condition. Like we have the boundary condition UA0, UAT is equal to alpha 1, UBT is equal to alpha 2, and from the previous slide, we have U is equal to Ci minus 1 plus 4 Ci plus Ci plus 1. Now, if we put I is equal to 0, if we put substitute I is equal to 0, we have U at 0 t. That means at the boundary, starting point is equal to C minus 1 plus 4 C1 C0 plus C1. So by using this condition, this is equal to alpha 1. That is alpha 1 is equal to C minus 1 plus 4 C0 plus C1. So we can easily calculate C minus 1 is equal to alpha 1 minus 4 C0 minus C1. Similarly, we will calculate the Cm plus 1 by using the last boundary condition by alpha 2 and substituting it in the given problem. We will have a system of linear equation where the number of unknown as well as the number of equations are same. Now this is the equation, this is the system we have, initial system. This alpha A1 is representing 1, this is 4, this is 1 for the given cubic B-spline function. So first node is A2 plus 2A1 and last node is chain, otherwise the complete system is diagonally dominating system, tridiagonal system. This is for the initial C for time is equal to 0. If we have the weighting coefficient C, time variable, time quantity at time t0, we can easily calculate the first and second derivative at time 0. Now, when we calculate the time derivative for initial, when we already calculated the initial system, then we have to find the recurrence relation for the iteration. For that, we have to discretize the RL equation, regularized long wave equation. That means which given in a problem, we discretize it by using the forward and backward difference formulas. We get these values and we get the relation between the j plus 1 LHS is in terms of j plus 1 and RHS in terms of j. So these values are known, and for these values we have to calculate the value of C, weighting coefficient. When we calculate the value of C, initial we are already know. So because in a previous slide we calculated the C0 initial vector, initial weighting coefficient. By using this we get J is equal to 0. We get the value of right side complete function and left side is unknown. Then we get again the system of linear equation like AC1 is equal to a known value RHS. By solving this system, we get the value of C1. Then again, we shift J is equal to 1. So this is the solution which is generated by the collocation technique of cubic. This is the RLW solution for the given boundaries when X is from minus 440 to plus 60 and time is from 0 to 4. X is from minus 40 to 60 and time is from 0 to 4. The exact solution is this, and this is the numerical solution. We cannot find out the difference between exact and numerical because the accuracy of the numerical solution is up to 10 to the power minus 4. This is the error graph. And I would like to show you the MATLAB code which is working on it, and even I can explain it. Is my screen is visible? Is MATLAB is also visible or only the PPT is visible?
Yes, sir, your screen is visible, sir.
MATLAB is visible or
No,
PPT?
sir. Only PPT are visible.
Okay, sir. Now is it visible, sir?
Yes, sir.
No. As well as the MATLAB script?
Yes, sir. Only MATLAB script is visible, sir.
The code is visible, no?
Yes, sir.
Yeah. In this code, the same problem is for minus 40 and ending point at the space is 60 and time initial time is T0 and last time I consider
Code is not visible.
Sir, please try again. Now there is some problem.
Code is not showing on our screen.
Sir, now code is not visible.
Now, sir, I think it is
Yes, sir.
Yeah,
visible
now okay. Now
Yes,
okay.
sir. Now it's
Now
fine,
Okay,
sir.
So for RLW problem, we are considering the starting domain as a minus 40 to ending domain as a 60 space, and time is from 0 to time is 4 and H again this is the H is a partition in a X space and K is a partition in time. Then this is the value of M and N we calculated by the last node minus the last boundary minus by the divided by the first boundary and divided by the number of partition, how many partition you require, and what is the K. So this is for the loop, and these are the parameters for RLW like alpha, mu and eta which is given there, and the F which is the disturbance frequency in a RLW according to the domain. From the previous paper from which I am comparing it, the value of F is this 0.5 square root of mu C upon mu V. This is according to the code, and then this is the initial condition we have to give first, then boundary condition we have to define, and the exact solution. We require the exact solution to justify whether the numerical technique we are using is accurate or not, or what is the accuracy rate. because we have to calculate the convergency and stability. So we have to find out the error. Whether the equation, the technique is used only for the numeric partial differential equation, but we are considering one model where we are justifying our technique. So we require the exact solution to get the error. Now these are the cubic B-spline function which is required, like which I explained that Ci minus 1 in PPT, in this PPT. Is the PPT visible? Or only one thing?
No, sir.
Okay, if you noted down that in a PPT equation B, in equation B, first equation is 1 Ci minus 1 plus 4 Ci plus 1 Ci plus 1. So the first Ci minus 1 is 1, Ci is 4, and Ci plus 1 is 1. For second derivative, the value is Ci minus 1 is minus 3 by h, center value, because in second derivative, we are not having the center value at Ci, so it is 0, and Ci plus 1 is 3 by h. Now for the second derivative, this is the for the first derivative. For second derivative, we have 6 upon h square. Center value is minus 12 upon h square, and the ending value is again 6 upon h square. You can easily see that this is the diagonal domain, diagonally matrix. Now using this matrix and after discretization, putting the value in a discretization technique, we are getting the solution. And solution is, this is the solution. Is the solution is again visible?
Yes, sir.
Or only one thing is visible, sir?
Solution is visible, sir.
Okay, sir. So if now I welcome everyone. If anyone having any doubt, if anyone, any participant, have any doubt or query, then they can answer. They can question me. I think there is in a chat box.
No, sir.
Vivek sir, would you like to ask anything?
No, sir. Everything is fine, sir. Thank you for this wonderful lecture, sir. You explained the things very well with the help of MATLAB software. You discussed the wave equation, Laplace equation, Haight equation, explicit method, Crank-Nicholson method.
I just want to say one thing to the participant, that
Yes, sir.
never fear with the MATLAB. MATLAB is just a most easy software. You are going through with it. You just need a maximum 1 or 2 hours practice maximum.
Yes, sir.
Then you will be friendly with the MATLAB and the tools. But you require the logic to create the program. Like a mathematician is required to find the factorial of 5. Then what is the logic? 5 minus 1 minus 4 minus 1 minus 3 minus 1. This is the logic. You require the logic to create the code. Thank you, sir.
Thank you very much, sir. Thank you, sir, for this wonderful lecture. Now our principal, sir, is online. Now I would like to invite Principal SGR PG College, Dehradun. Sir, please bless us with some few words.
I hope everybody is listening me.
Yes, sir.
I was able to listen the first lecture given by Dr. Singh on the first day on the opening of this wonderful conference of the mathematicians of various countries. The 5 countries, universities, mathematicians were participating, and I hope in 5 days, maximum faculty members of various colleges of Uttarakhand, Uttar Pradesh, and various other parts of the country and other countries, they must have benefited. Today, fortunately, I was able to listen Dr. Biswajit Sarkar's presentation and his lecture. In fact, this lecture, I feel, while he is a hardcore mathematician, but I feel it was really very good for the people, those who are minutely working on the environmental studies. Then as far as sustainability is concerned, for example, long back I was working on a model given by Alan Prescott, and where there was a problem how to measure the sustainability. Actually, just to tell about the sustainability is a different thing. But for example, Dr. Biswajit Sarkar was telling about with the help of the mathematics and all these, and there were various other things like pollution, then environmental things. There were many things which mathematics can solve with more accuracy, more accurate. Actually, to implement any plan related to environmental issues needs more accuracy, more accurate policy is needed. That's why his presentation was very much useful for all the research scholars, those who are researching, the people, those who are working in the various fields. So I was much impressed by his presentation. First day in the opening session, I was not able to see the presentation of Dr. Singh from Chaudhry Charan Singh Merit University. But overall, I would like to congratulate those who helped our college from various parts of the countries. For example, Dr. Sarkar, for example, Dr. Singh and Dr. Mohammed, those who were giving all support with the help of their own presentations and their own research work. So I hope our research students, our faculty members, because learning has no end. So I think our faculty members, the researchers, and the students, those who are coming for higher education or those who are going for the more higher education, they will must be benefited. I was able to see the presentation of Dr. Neeraj from Graphigara University. It was also a very good presentation. While it was more good for the mathematicians, while I was not much capable because there was some problem in the beginning. But see, once he had given the solutions with the help of the MATLAB, that was wonderful, particularly for those who are students still doing research in our institutions. For them, it is very good. So I would like to congratulate Dr. Neeraj that he had given a wonderful, very good presentation, because the mathematics is a different kind of science, but it is a science which is to be used nowadays in every discipline of education. So I'm highly thankful to all of you, and particularly I'm thankful to my staff member, Dr. S.K. Padalia, who was organizing it, Dr. A.P. Singh, and Dr. Vivek, those who were working for it for last a month. For last 1 month, they were working for it. So I would like to congratulate every and each, because I am sure that everyone whosoever was in this conference, they must have learned a lot. Thanking you, sir, for participation, and thanking you, sir, for contributing your vast knowledge in this conference. Thanks a lot again and again. Thank you.
Thank you, sir.
Thank you very much, sir. Now, I would like to invite Dr. S.K. Padalia, Head Department of Mathematics, also convener of this webinar, for vote of thanks. Please, sir.
Thank you. Am I audible, sir?
Yes, audible, sir.
Thank you. It is
Yes.
my privilege and pleasure both that on behalf of Department of Mathematics, SGRR PG College, Dehradun, the international webinar of mathematics in our department from 14 September to 18 September 2020. I express my deep sense of gratitude to all participants, especially our esteemed experts, invited speakers, and especially keynote speaker, Professor S.R. Singh from CCS University, Meerut. His highly illuminating and useful talk on basic concept of inventory management. He said he developed mathematical models solving real life problems. His study is interdisciplinary, so it was very useful for the researchers in multidisciplinary area of working. I also thank our key speakers. He has given valuable time to our college, to our department from 14 to 18 September 2020. I hope that every session was quite fruitful for the mathematicians. In day one, another speaker was Dr. Mohammad Tamsir from Jajan University, Saudi Arabia. He delivered his talk on numerical approximation of Fisher's reaction diffusion equation. Thank for him for the lecture. Again, in day one, we have a talk, Dr. Mukesh Kumar from MNNIT, Allahabad. Topic of the talk was exact solution of non-linear partial differential equations. It was very interesting and very useful talk for the participants and the college students also. In day two, first lecture was of Professor Anita Tomar from Government College of Uttarakhand. Topic of the talk was on geometry of non-unique fixed points and Mexican head type of discontinuous activation function. I am also working with her. Our two papers are accepted for publication, are in press. One in Journal of Application Analysis from Berlin, and second one is Application Maths e-notes from Taiwan. Second talk was of Dr. Nagen Sharma from Taiwan. Some technical glitch, he could not join with us. Then he delivered his lecture on third day, that is on 16th September 2020. In day three, Dr. Mukesh Kumar Avasthi from Bhim Rao Ambedkar University, Lucknow. His talk was in interfacial instabilities in fluid flows. And the second lecture was Dr. Anand Singh Chauhan from Graphic Era University, Dehradun. His topic was fuzzy optimization techniques. In day four, Dr. Vinesh Kumar from Muscat, Oman. His topic was basics of fuzzy set theory and its applications. And the second lecture was of Professor N. Sukhvanam from IIT Roorkee. And the talk was very interesting and very useful. Topic of the talk was stability of dynamical systems. In day five, we have with us Dr. Sarkar is there, Dr. Viswajit Sarkar from South Korea, applications of sustainability in supply chain management. And the second lecture was Dr. Neeraj Dhiman from Graphic Era Hill University. And the topic of the talk was numerical solutions of partial differential equations. So I would like thank all the invited speakers. 11 speakers was there and they have given their valuable time for us. We always thank them for this webinar. So now we have also thank our principal sir, Professor Badai ji, for all time support. I also thank our important colleague, Dr. AP Singh and Dr. Vivek Kumar and the technical support team of our college for making all the arrangements and this conference successful. We believe that such type of activity to promote mathematics with the help of intellectuals and their interactions to enhance the quality of higher education. We really appreciate the efforts of our learned speakers working in the field of pure and applied mathematics. Again, from the core of my heart, I really thank all the participants and professors from India and abroad. Thank you very much, sir. Thank you very much, sir.
Thank you.
Now we will leave today. We'll meet again.
Sure, sir.
Thank you, sir.
Certificates will deliver within 10 days. Our technical team working on these lines and these points. Thank you. Thank you, sir.
Okay. Thank you, sir. See you sometime.
Thank you. Thank you, sir.
Thank you.
If anybody wants to say something, participants, Devendra Kumarji is there. You want to say something? Thank you, sir.
Okay. Thank you, sir. I'm leaving.